Good afternoon, good morning, good day to all of you from across the world, and welcome to Haystack Live. This is our occasional meetup on search and relevance issues. My name is Charlie Hull from Open Source Connections. We're the search and relevance people, and we're very happy to host Haystack Live. So we've got a fantastic presentation coming up today, but before we start, just a few housekeeping rules as ever. We'll be recording this presentation for later publishing it to YouTube on the Open Source Connections account. If you could please keep your microphones muted. If there's any significant background noise, I may have to mute you myself. If you have questions for our presenters, please do drop them into the Zoom chat, and then following the presentation, I'll ask those questions on your behalf. I may ask you to contribute if I can't understand the question or there's some extra discussion to be had. A few other things coming up soon. Firstly, we are looking for more speakers for Haystack Live. So if you've got a great search and relevance story, please do submit it to the form. You can find that on the Haystack website. And of course, the big news is in about a week and a half, we have our in-person Haystack US conference in Charlottesville, Virginia, the home of OSC. And we've got a fantastic lineup of talks, 2 tracks of talks over 2 days. We actually have an online option as well. So if you can't make it to Charlottesville, do check out the website. There's now the chance to get an online only ticket, and we'll be making it possible for you to ask questions as well if you're joining us online via a couple of Zoom rooms. There'll also, if you're in Charlottesville, there'll be panels, networking events, social events, drinks and dinner, all that kind of stuff. And we're really looking forward to welcoming you all back in person. So do check out Haystack. There are still tickets available, but you've only got a week and a half, so do get cracking and get involved, and we'd love to see you there. So our speakers today are going to be telling you a lot about Elasticsearch, Enterprise Search, and they're both from Cisco. So without further ado, I'm going to hand over to Sujith and Prem, who are going to tell us all about Elasticsearch and the AI-powered Cisco Enterprise Search platform. Let me just stop sharing my screen, and please, over to you both, gentlemen.
Thanks, Charlie. Let me share the screen. Good morning, everyone. This is Prem, Malhotra, and Sujith and I will be sharing with you the work at Cisco, and hope it's enjoyable and you like it. So I am leading the team of search and AI engineers at Cisco, responsible for search across external as well as internal requirements. And our goal is to bring the information in the most usable and delightful way to our customers, partners, and employees. And specifically ranging from the external facing support content to internal facing content for how to handle support issues and the non-technical content and the whole 9 yards of it. And our goal in the last few years has been to combine the search with some of the AI capabilities to make the search better. And what you'll see today is some aspects of that. And Sujith, if you would introduce yourself.
Sure, thanks, Prem. So I'm a chief architect for enterprise search and cloud in the enterprise AI organization at Cisco. I'm also a GCP certified cloud architect, as well as Kubernetes certified as well. So I come with around 17 years of experience in enterprise search. Have worked on multiple generations of enterprise search engines, like starting from Verity, Autonomy in the early 2000s, Fast, TVO, Solar, Elastic, etc. I'm also, a co-founder of two meetups in Bay Area as well. Back to you, Prem.
Yeah, thanks, Sujith. And so I'll talk first and then hand over to Sujith maybe in about a half an hour kind of mark. And so the example that I'm going to give you about the search, we have multiple ones, but the one here that we're talking about is the Cisco.com search. So this is what you see on a search icon on Cisco.com pages. Typically, it has about 5.5 million searches a year, and it's deployed worldwide, multi-region and so on that we'll talk about. And it primarily caters to the marketing and the support and sales view of our customers. And the most visited app on Cisco.com, available in multiple languages. So before this transformation started, this was running on a legacy system that kind of lost support. But that, along with the incentive to say now the chance to do something different, is what led to this transformation. It's called Reimagine, Cisco.com search that got live about 2 years back, less than 2 years back. And that reimagining of other search is continuing to happen. And here are some of the key changes that happened. It's moved to cloud 100%, moved to Elasticsearch as a core, and then added some AI-driven capabilities that you could actually flesh information out of the long documents that it had to kind of help you in your information needs, and much faster across the globe. So you see here how the response times decreased significantly, especially in the Far East, Australia and Singapore. Now, what key thing it did in terms of getting the content on your fingertip was, if you think of Cisco as a book club, and then it is finding the right book, which you would typically search does, and then turning it to the right page to be able to take paragraph-sized contents or slightly longer, depending on the content type, and show it to you in response to the search request. Other part that happened here is that because we have so much rich, dense content, I wanted to show to the users that here's the kind of information that exists in the system. So that was brought through what is called type aheads. Search type aheads are well known, but we kind of enhanced that capability to be able to generate questions from the content as the user interacts with the system. So first step is to show you what it is, and then we'll talk more about the rest. Okay, so this is what you see as a search result page as you click on any search icon on Cisco.com. And let's want to try some searches here to kind of illustrate the innovation and the change that we did. So 8000 happens to be one of the Cisco products. And so he says 8000 series. And you see this drop-down type pairs that are coming in here. So there are a few of them on the top are handcrafted. Everything below that is generated by the natural language generation, looking at the content and spitting out these questions that have been processed to make sure that they're clear enough. But what that was meant to do was it is showing that what exists in this content. So there's a fair amount of technical jargon out here, but what this really brings about is a kind of question that you can ask, and people can click on them, or it can be something that inspires you to ask more. So in this case, I just click on one of the questions, and this was a question about some reload or some tunnel in the networking lingo. So what it shows here is the snippet that is in this box, which is essentially picked up a piece of that content from a larger document. And this one particular one was talking about some symptoms in that product and how to kind of find a solution to them. And this comes from this document that's listed here. So the goal was to be able to do these kind of things in a smart way. Let's try something more. So there is a feature called NetFlow. So I say configure NetFlow in the same product. And you have a bunch of these configuring questions that came out, and you can click on that, or you can take some sampler, procedure, and so on. So let's look at one of the procedure. And this kind of shows you the title. Title typically comes from the headings of the content, as well as sometimes it is AI generated, and I'll show you how. But in this case, it is configuring that feature in this product. And it is a content exactly plugged out from the document. So we are not in the business of generating content. We are in the business of showing you what already exists and what you should look at. And all this is followed by the organic search results below that. And the goal of this feature, which is called Deep Q&A, has been only give an answer if you really know about it. Otherwise, don't waste the customer's time. Now, not always you need to type ahead. Like this case, this is Lexus 9500 is another product, and you want to know about the line card capacity of this thing. So you didn't find anything that was valid there. So now a search happens across the snippets that exist. So you see here the first snippet, which is talking about here are the different line cards that are available. So it plugged that from a data sheet of this product, and so giving you the capacity and different other descriptions of that. So right in the beginning here, showing you the 4 8-slot line card capacity in terms of terabytes and so on. Let me do one more, which is inspired by a kind of problems that customer might incur. So they might say things like this. So let's say there's a customer that has a problem called output drops. And this is inspired from a real support case. And this product that they're talking of is CAT 9300. CAT is the acronym for the catalyst, so the system understands different ways to talk about it. And so this is a search request, and customer wants to know, what can I do? So look at the title here. This is plugged out of this content, but this is not a heading. And when you look at more, you're finding here a very crisp description. So this problem is known to us, and it is actually surfaced in the appropriate documents on Cisco.com, customer facing. And we have picked out exactly the section that talks of this product, Catalyst 9300, and what happens when the output drops, what's the cause of it. So what this is all illustrating is the ability to turn the page of the book. And so these documents are actually much larger. So you got to the book, you pick the piece that you needed. Now let's go back to the presentation to share how it all works. So the key things that are that were done here is going from left to right, clockwise. The first part was document chunking. So chunking is needed to be able to pre-process these large content, which are typically HTML, and so they retain their organizational structure that are fairly easy to pick on. Using those chunks, then generate this type paired question, the several questions that you saw there. And then next one is once a query happens, how do you match query to the type paired if it is not exactly clicked on a type paired? So it's a close match capability. And then how to use these AI models that are under the cover respond so fast. You saw the response times are very spiffy. So going to these documents. So the system, the Cisco.com external facing site has the support documents of these different kinds. They're differently formatted, and there are about 350,000 of those. And they're not all identical. So the parsing schemes had to be devised so that one can actually process all of them. And here's an example of these documents. The end user guide has a data sheet. They look very different. And one of them is more like a procedural steps. So there is more of a feature description, so on. So what do we do there? So what this parsing does is it essentially creates a document tree, and documentaries are kind of looked at in terms of the titles, subtitles that you can get from the HTML. And then in some cases, the rules are applied to say if the content is very tiny, then you combine some of those headings together. So about 350K documents gave about 3.5 million snippets or chunks. And here's an example of a documentary from one of the documents. So what you see here on the left is a tree, which is with the titles and subtitles. And what you see on the right, and this blue arrow kind of shows what were combined together, the subsections into one chunk for IP fabric for media solutions on topic. So the subheadings you see under document types are also part of this slightly larger chunk. So how was the type heads generated? Now with 3.5 million chunks, really any human effort is kind of wasted if we do it manually. It's not worth it. So what was done is these were parsed, chunks themselves were parsed further into smaller units. And then they was fed to this NQG engine, which is based on sequence to sequence transformers. And what it does is given the text and a hint about the text, it generates questions, about 2 or 3 questions per chunk, per subchunk. And these questions are then assembled together for more rule-based sorting, so that some of the very trivial ones are checked out. So from 8 million questions that got generated, 1 million were left, and then further processing by looking at the lexical quality of the questions, only 360K were left. And then there were type heads also generated from very good headings. So the headings themselves are very nice. So why not use them? So you see a lot of those in the system as well. So what did we do to really sort them into a smaller set is important, because again, these numbers are so large, it can't be done manually so easily. So we deployed a technique for lexical quality. I'll show that in the next slide. What you see here is what model was used. So this is off-the-shelf model from one of the teams in Microsoft that is open source that we used. And it's a transformer model, which is essentially leveraging ability to, for the training, it was trained on Wikipedia and content. So it could be used for this language translation, summarization, question generation, and that is a feature that we leveraged. And the way this works is that because this AI model understands the language quite well, English is what we are kind of dealing with here. There's a fair amount of transfer learning that we're able to leverage off the shelf. I was talking about how the questions were sorted out. So in the classic language processing, there are these concepts like token term ratio, and then measure of textual lexical diversity. So we took these measures which are well used from the content to see if we could apply them to our questions in a way that we could have a very objective way to see the good quality questions are kind of sorted out or picked from them. So the work in the middle is we combine these scores, and this was done empirically, and where we found that the question quality is quite good. And this helped us get to the 360K questions at the end. You know, what you see at the bottom here is how were the hints generated for the model. So this is using the spacey parsing to pick out the entities. So very basic entity picking was done so that these hints are given to the model to say, generate a question, and questions typically will not include the hint. So around that hint. Now getting to the answers. This is the next step in the process. So you have these type heads and they're indexed in their own index. And so customer query comes in there, and there's a couple of other things we do. We also do what is called deep CT. This is another transformer-based, BERT-based model, which assigns higher or lower weights to the terms in the query, and kind of helps in focusing the search better. And then it goes to the elastic retrieval. So the first retrieval is this whatever customer has typed is actually close to some type head. So it's looking the type head index. So we also fire queries in parallel to that, as well as to the regular content, which is a full index of all the chunks. And the third one is to the document index as well. So there are multiple searches going on in parallel. In this particular case, this is showing an example of a query being checked if there's any type head close enough to it, that we can say pick the type head and then go to the chunk or the snippet which corresponds to the type head. And you see here a squad model. This is the third one. This picks up some text to show in the heading of that when the model is displayed. And this is not always needed. If there's a good heading, we just use that. But in some cases, we kind of find that the type heads are better represented by a model that picks up some snippet, sentence inside the snippet. And that is what squad does. Squad is basically using, again, BERT out of the box. So this is a standard model that Google kind of came up with in 2017 and has been kind of the foundation of the NLP and across NLP now. So DeepCT, this is the one that gives you relative weights. It was trained on Cisco's 40,000 FAQ kind of question pairs that were manually created for a prior work, which is prior to the system. So the last piece here is on being able to figure out, okay, you got the query. Did you find it in the type head? So this is a flowchart around that. And if it's not found in the type head, then fire a query on another index, which is the index of all the chunks. And the important thing is that if you find a product, is much more confidence is higher that this is actually the right piece that you're looking for. And if not, then you call it with the concepts that are top concepts in the query, and then fall through that to the bottom for the answer. Now, this same technique that we used here, it has been reused in multiple other information offerings. So this one example here is case deflection, and the context is that if the customer is trying to open a support case with Cisco, can we help them in that at that time with information that might give them an answer instead of them opening the case? So this one leverages similar technologies, but it is working on a more rough or less accurate input. People typically type in this left-hand box a larger description with a lot of attachments and so on. So it has to sift out from that. Is there enough quality of the information available? Is the product mentioned? Are some other attributes mentioned? So what you see here on the left is intent detection was brought in here. What is the intent of what user is telling us? And then what are the different slots? Slots are the entities in the domain, what the products, their features, software names, software version numbers, and so on, that we can pick from it to give a score at the bottom. This yellow line is a score to say this is the strength of the information the customer you have given us. Can you give more? And then on the right-hand side, it comes up with the similar recommendations for chunks from our system using the kind of technology that I showed you before. So going to the actual deployments, as you know, the search response time is very important, and anything which runs in hundreds of milliseconds will basically become a liability. So a lot of these models that we pick out of the open source, they are not tuned to run fast enough. And this was another effort that we did to be able to get them to respond in tens of milliseconds, not hundreds. And the technologies used there is what TensorRT. So NVIDIA offers this open source Triton server, which leverages, which can run the models that have been fine-tuned for TensorRT, and there's a well-documented process to do it. Some come out of the box like that, others not. So this is an important part of deploying something in production that is spiffy enough and can be used for inference. So highlights of this work is that AI techniques can be effectively integrated with search, but you need a certain amount of patience there. And there's a lot of open source NLP models available. You don't have to create them from scratch, but learning how to apply them is where the challenge is. And analyzing the content and being able to visualize what you want to do is most important here for the experience. And this is kind of exciting area because the capability of leveraging what is open source is so good. And at this point, I'll hand over to Sujith and to kind of talk about the rest of the system and what we do. Thank you.
Let me switch to sharing. So while this loads up, right, Prem talked about how we used AI and chunking of Cisco.com documents to power a Q&A on Cisco.com search. And the same index essentially with additional AI techniques like NER, intent detection, summarization, etc., was used to power case deflection as well. Now, this is the next use case I'm going to talk about is the use case for case assistance for support engineers. Cisco, this is the support engineers which caters to all the Cisco's customers for all our products as well. So what we did is we built a solution which would recommend historical cases, support cases, to a support engineer based on the current case that the user is working on, based on the textual data that is part of the data and that is powered by embeddings. So the first version that is used today is based on embeddings based on Autosuggestions, and we are in the process of rolling over to use the sentence transformer based BERT based embeddings as well. So let me at the high level, it provides embeddings based similarity based on multiple fields, and there are fields that are based on, say, the title of the case, the problem description, the body of the case notes, etc. And there are different kind of matches. And then there are key phrase based matching and embeddings based on the key phrases, which goes into, and there's also some of the search queries that are used to land on the cases by a search tool that we have. All those were, embeddings were created at, and we had multiple layers of embedding matches to power the solution. Now, what's interesting is in initial versions of this, probably 3 years back, this was rolled out as a cosine similarity with entire similarity happening within microservices, and the models being loaded up there and served out, and that was not scalable. And then we moved to Elasticsearch based plugin. This is a Canon plugin from distro, which we installed on top of Elasticsearch running on Kubernetes, and that was giving us, the hierarchical navigational graph based HNSW based embeddings based similarity in a much faster manner. So what we did is, for the given case that the customer is working on, we have a system which on real-time computes embedding anytime the case is updated. And for those embeddings across a variety of fields of the case, it's matched against all the historical millions of other support cases that we have, based on filtered on a certain groups of technologies associated with that particular case. So we have AI-based clustering, which was finally used for this particular set of groups. So the recommendations were generated, and then for every, and we used to cache the results so that the response time is fast. And anytime the case is updated, we use to recompute the embeddings and cache the results. And then what you see is a small example of a recommendation of the results for a given case. And this and the below section that you see is a summary of the case. Because if you're doing a search, you can use the highlight in Elasticsearch to generate the summary. But when it comes to embedding with similarity, we don't have one. So on a real-time basis, for every support case that we get, we have a system which would go ahead and compute the BERT-based summarization. This is fine-tuned on our support cases, and that gets cached into Elasticsearch, and that gets served real-time during the result display. So as to the speed, as I said, right, because we're using the Elasticsearch plugin, it's working out great. We get with even case 10,000, we get less than around 50, 60 millisecond response time. Even with the M search, we do around 12 different types of embedding comparison real time. Now now that Elasticsearch with the 8.x version has that inbuilt vector search capability, we are working on moving towards a native vector search comparison within Elasticsearch as well. The next use case is something that went live last year. Ciscocom went live. All the work that Prem talked about went live 2 years back, July, I think around July 2020. What we did last year was focusing on the rest of the migrations into this new platform, which we call the Reimagine Search platform. And one of the major and one of the biggest implementations in terms of volume of the data is a tool for our support engineers, which we call topic search. And TAC engineers are Cisco support engineers. And this is a tool that is used by the TAC engineers to solve around 90% of all the cases that Cisco receives across all the products. What it does is allows a search on historically all the product support cases, the case nodes across all the products historically, all the bugs, Cisco's internal bugs of all the products, all the knowledge articles, the news group articles, PSERT and things like that. There are around 43 different data sources that this search and also the attachments associated with the bugs. The attachments are pretty huge, and we have processed and we chunk those as well. In terms of volume, it's north of around 50 terabytes of index that we bring in with this search on this topic search. So and one of the most important thing is for support engineers when they're all on a call with the customer, and they do the search live on this tool, and one, they need the results to be relevant. Otherwise, it has a huge impact in the response time to the customer, to the speed as well. Search has to be fast enough. And these were the two goals, and we did a pretty good job in nailing these two with AI and the Elasticsearch tuning and relevancy as well. So some of the things that we did for our topic was one is key phrase extraction. So we use a keybird. I've put in the link in there. We use a keybird which would extract the key phrases from the query, and the key phrases from the query was used to, in a way, enhance the query that gets sent to Elasticsearch. Yeah. It gets a different boost and gets a different, phrase search mapping, etc. Now, the other thing that we use is the same thing that we reuse. Some of the work that we did in Cisco.com search, we reused it. That is the deep CT that Prem talked about. Here, we use the contextual BERT attention weights of the keywords to use that information to figure out a specific additional boost criteria to the Elasticsearch query formation. And yeah, and then for the key phrase extraction, we use, and if you look at the link, you'll see that it uses the n-grams and the embeddings of the n-grams, and it uses marginal relevance MMR factor to figure out um, which are the best key phrases, and that has produced some interesting results as well. On top of it, synonyms based on Gensim embeddings, which are pre-computed and stored in Elastic, are used to enhance for query expansion. And the third one that I want to highlight is, we used a model which is essentially a Bayesian model, um, which was used to predict the Elasticsearch relevancy, at least the foundational layer for a relevancy model of Elasticsearch. This was based on a blog that Elasticsearch has published, and it also gave us a good starting point for us to tune the relevancy. So what it does is, given a set of click data based on the dwell time or the user engagement, we have a golden set data for the query and which are the best documents for it. And given that information, and you feed it to this model, it tries, and you give it multiple variations of the queries, and for each of the query variations, you give in different ranges of boost criteria. So, say for example, then the traditionally, we used to do this, trial and error as a manual operation. Like, okay, I have a query, I have a golden set, or someone says, this query is not working. You go and fine tune, you tweak the boost values for certain field matches, like say, the title or the description and content. You tweak them and see, does my DCG score overall becomes better when I make some changes in my relevancy boost across certain fields matches. Now, this is an approach to automate that end-to-end, to say, here is my golden set, here is my Elasticsearch instance, use the rank capabilities within Elasticsearch along with this Bayesian model to run a job which would compute for every different variations optimized by the Bayesian model. It'll ultimately lead you to a recommendation to say, this is the recommended relevancy boost values or the query variations, say an and versus or query by default, things like that. This is a recommended model that would give you the closest results that gives the best NDCG score in terms of your golden set. Right? That is what ultimately this provides. And there is a sample notebook that is already available in the Elasticsearch site. Yeah, we use that, but was it perfect? Not, but it gave us a good starting point and gives a lot of insights to see, what was the most impactful fields and how much should be the boost variance as a starting point, and then we started tweaking from there. Yep, and let me go into this is some of the feedback that we received from our customer support engineers. It's very difficult to get. We roll out an enterprise search solution and get good feedback. We've been doing that for since 2007 at Cisco. This is the first time using a custom solution that we built using our own homegrown AI. We got a very good feedback from our support engineers, speed and the relevancy that mattered. And one of the callouts that even with Elasticsearch relevance, we use the intervals query a lot, which essentially helps in proximity matches. So we had even though the Elasticsearch relevancy model, the query is pretty long. The template, the number of lines in the template was very big. From a speed perspective, we were able to nail it down to a pretty good one. And part of it is attributed towards the relevancy model optimization, and part of it is the work that we did in GCP. So we memory mapped the entire Elasticsearch index. I'll talk about it in a minute. So yeah, so the next part talks about how we build this enterprise search platform. Now, typically, if you go with any vendor solution, you can see that there's connectors and there are crawlers, and there's a document processing framework, and there's a search engine, and there's a query processing framework. and then comes the UI and things like that. So essentially, what we did is we picked up components of GCP um, that met our needs in terms of the different layers, and some of the components were you know execute as managed service of GCP, and some of them were running as microservice in GKE, and I'll talk about that in detail how we build it. And this is using a modern, very modern technology stack, um, and this is what the GCP team had to talk about the work that we did. So the entire thing was done in 8 months during the COVID time, the start of the COVID time. And the AI, both the AI part as well as what Prem shared, as well as the backend part, was all done with a very small team. Less than 20 people working on this to get this um, going live in July 2020. So let me talk about the anatomy of the enterprise search platform. So as I mentioned, right, there's a data layer, there's a connectors layer, API, web crawler layers, AI, document processing workflows, search engine layer, cognitive AI query processing layers, and API management and things like that. You all must be familiar with this. So in terms of data, right, just for the Cisco.com purposes, I'll talk about it, right? We had the authoring tool that is used for Cisco.com is Adobe Experience Manager, and that is on-frame. And we had content that is running in databases. We have websites, and we have videos and community content available via an API-based endpoint. So what we did is, for Cisco.com, traditionally in the previous implementation, we used to have a crawler which would go and crawl Cisco.com and to find changes, etc. We moved that to a push-based approach where anytime an author publishes a content real time into Cisco.com, an event is sent to PubSub. The document gets uploaded to Google Cloud Storage, and then the PubSub event with the Google Cloud Storage URL gets sent to us, and then it goes into a processing workflow. For all the other connectors, we have standardized them on Spark. There are two reasons for it. One is the distributed task execution of Spark was very helpful to give the fastest fetch, whether it's a database or API or even a crawler. That was the fastest that we could see. I'll talk about crawler in a minute, but essentially we evaluated multiple open source crawlers out there, including Notch. Notch was pretty bulky. We evaluated a couple of them, and some of them JavaScript based, some of them Python based, and Heritrix. We tried it. We found out one particular crawler, an open source one from a university in California, was the fastest. Essentially, all the crawl fetches was done as Spark jobs, and it was had a lot of missing features needed for our use, and we added those features back, and sometimes we'll open source it back as well. So, and for the API as well as the database, there's Spark has got standard data frame loaders to do load it, so that was easy. This is the crawler that I was talking about that we used, and we added the incremental crawling capabilities and authentication capabilities, and a lot more capabilities that is needed to be robust enough to run an enterprise scale. So what on a GCP cloud, we ran this as a Dataproc job, so that essentially, these jobs would get VMs would get spinned up on the fly. Dataproc job would get executed on those VMs, and the job is done. It would scale it. Now, what is interesting is all the checkpoints, etc., stored in Cloud SQL. Now, we also there are certain scenarios where the data was on-prem and it's not accessible from the cloud. So I'd install a open source Kubernetes on our OpenStack platform, and we had a Spark operator installed there, and it is using a gang scheduler known as Volcano, which is pretty stable, pretty seamless. And interestingly, even though the job was running on-prem, the state of the crawler, the checkpoints, etc., are stored in the cloud in Cloud SQL. So even it's kind of running as a stateless pod, even though it is running on-prem, so that even if there is a node issue, it'll pick up from where it left off next time, and another pod gets pinned up, etc. So yeah, this is what it's talking about. The checkpoint in the meta store is Cloud SQL. All the documents, when it gets fetched, by default gets uploaded to Google Cloud Storage, a gateway service. And the crawl document, that is the GCS URL of it and the metadata associated with it, gets sent to GCP PubSub, and that is picked up by a document processing workflow. So one of the things that we've done is traceability. And in all of the previous implementation that we had, one of the challenges that we faced is the document is fetched, it is there in the crawler logs, but it is not there in a search index, and we don't know where it got lost, right? When we designed it, one thing I want to make sure is, all the issues that we had across all the products of enterprise search that we've had worked on in the past, 10 and 14 years, I want to make sure that I bring in all those solutions to fix those issues into this new platform. So, and GCP as a platform leverages pretty easily to add in this quick features or nice to have features that we thought was missing in enterprise search product. So any component that touches the document and that goes in the system, whether it's a crawler connector, the crawler, any component in terms of document processing, any components like indexing, for example, like from Logstash, we have an event that is sent with the document ID or the chunk ID into a PubSub. We call it as event PubSub. And what it does is it tracks two things, right? What is the time taken by the processing system? How much time was it taken for doing processing of that particular document? Whether there's an error scenario, whether it's success, and what is the component that tested? And this is also used for, say, alerting purpose. Like we have a priority flag. If there's an error scenario, there's a priority flag to say, from a scale of 0 to 10, which we use for, say, alerting purposes. That gives complete visibility into the journey of a document that flows from across different components. And ultimately, once it gets successfully indexed in Elasticsearch, we have a view into the traceability of it. So this goes into the Elastic. We store all these events on PubSub into Elastic as well as in BigQuery. BigQuery contains all the historical events, and Elastic contains the events for just last 2 weeks. So if there is an errors during the crawl, we dump that data automatically in the big table, and that's used for any refeed, etc. So far, it has been pretty good. But we designed that fallback mechanism pace so that we can automate the reprocessing if there's any errors in the crawling. We added things like form-based authentication, JavaScript based page crawling, duplicate content detection, the HTTP modified since header checks, the 3.1.3.2 redaction, etc., and a lot more. Now, this is the one we talk about where documents were pushed into the system whenever there is an update or document in the Cisco.com or a deletion of the document or even a redirect. We have ways to handle that as a push mechanism into a PubSub directly. So the content management system integrates with our PubSub and GCS and makes it easy for us to do it. So we didn't have to worry about figuring out changes. The biggest advantage is the changes were real time, right? This was much better than a crawler crawling the site. Now, next is the document processing layer. So what we use for document processing in GCP is Dataflow, and Dataflow is a managed Apache Beam. So Apache Beam is open source. So we use a streaming, not the batch pipeline, streaming pipeline of Dataflow. So all the components, all the connectors, running a Spark jobs would have a common endpoint that is PubSub for that is essentially the crawl document is GCS. The reference of that goes to PubSub, and this is a component that reads from PubSub and does the job of applying the business logic and doing text extraction, etc. And then the process document goes into the next subsystem, that is the indexing subsystem. So we do in this particular scenario, there are probably around 300 and 400 such components in the transformers in the Dataflow pipeline on a per use case basis. which would apply the business logic of mapping from the meta to the document to normalized entities, which can be used as facets in the UI, doing a text extraction, and for text extraction, we from the transformers within the Dataflow, we actually invoke microservices running in the same network, running in GKE to do the text extraction and things like that. We use the same thing for locale detection, and based on the locale that is detected, we apply different indexing, analyzers, etc. And there's errors, and it goes into Bigtable. As I mentioned, there is traceability that is added, metrics for each process of the microservice gets added, and as and when the volume of the documents increase in PubSub, Dataflow would automatically scale up and down. The worker nodes would automatically scale up and down. So in a specific Ciscocom specific setting, Prem talked about documents that comes to the system, and once the processing of the document is done in the Dataflow, it goes into another set of microservices which does AI-specific document processing as well as chunking of the documents into smaller passages, which can be used for Q&A. So this, again, and we have done as an event-driven mechanism with a different set of microservices which does specific functionality like chunking, and then the chunk documents goes into PubSub, and then it goes through multiple sets of AI microservices, which does things like natural language question generation and QG that Prem talked about, and ranking and filtering, all of it. And then the questions that are generated from those passages goes into the type head index as well as in Elastic via Logstash and PubSub, as well as it also goes as a metadata into the chunk, so that if the user clicks on the type ahead, we know where it was generated from. We can without doing much of a search, we can directly pull up the chunk and display it as the answer. And for other use cases, we use the similarity and actual search to figure out if there is no direct match, the user did not select an NQ generator type ahead, we do a search and AI to display the right chunk to the UI. So ultimately, the suggestions, etc., are, and as well as the chunks, are passed through PubSub, and it is indexed into Logstash. Indexed into Elastic via Logstash running as microservices. Again, all of these microservices have got horizontal pod autoscale enabled, so that it will scale up and down based on the volume of the data that comes in. So as I mentioned, the Logstash, we have multiple sets of microservices, Logstash microservices. Again, Logstash is also, since it is running as a microservice, we have HP enabled, so it can scale up and down. And what Logstash does is it picks up the reads from the PubSub. We have a custom Ruby plugin which would go download the documents from GCS and then update and sends it to Elastic. And then we have another Logstash instance which would read from Elastic for to see what are the new documents that come in, so that it completes our traceability loop as well. And we use, for all the Elastic secrets and the communication between the microservices, we use Google Secret Manager. So all the secrets are stored in Google Secret Manager. Even Logstash, reads from the Secret Manager to load up the Elastic traditions to talk to Elastic, etc. Now, one of the things when it came to, this is for Cisco.com, but when it came to the support content, because there is huge amount of data involved, we and some of the attachments sizes are huge, right? You can see for bugs that are attachments as high as 1 GB. In some cases, we chunk them. In some cases, it's pretty large. So what we do is, we have multiple sets of pipeline architectures, even in Logstash, which would, based on the size of the document, we route them to different PubSub, and the Logstash settings for each of those are different. For example, for a large document, anything greater than say 50 or 100 MB, we have a document, we have a separate set of pipeline settings. The worker CPU and RAM are different. The threads are different. The batch size is different. The timeout is different, etc. And because of the sheer volume of the data that we deal with, the support-related content, rather than Logstash sending that data directly to Elastic, which was exposed as a a network load balancer, like an external load balancer internal load balancer in Elasticsearch microservice. We routed via Istio. Istio is a service mesh where for our entire search cluster, including Elasticsearch, and that helped us to get visibility into the size of the documents, if there is any errors in submission from Logstash to Elastic, we could visualize all those in Grafana and Kiali, which essentially displays the Prometheus metrics, Prometheus Istio related metrics. So that was one of the issues that we had initially. We were using a traditional network load balancer from Kubernetes. When you're submitting large batches and large volumes of it, it'll lead to timeouts from Logstash, and it'll be unresponsive, and batches would fail. By routing via Istio and setting separate virtual services and timeout settings in Istio, and using an HTTP as a load balancer, Google's HTTP as internal load balancer, that helped a lot in making that happen. So based on the different sizes of the documents that we get, and we have different pipelines, and each of the pipelines have got a different Logstash as well as microservice level settings, and they have different Istio settings to deal with this, and that made this large volume ingestion successful. Now, when we talk about how we deployed Elasticsearch in GKE, so the Elasticsearch cluster, specifically with Cisco.com, was deployed in 2 Kubernetes clusters in 2 regions. That is in the US and Asia, and we had the data nodes spread across 2 zones within each region, and the master nodes spread across 3 zones. We use ECK operator to run Elasticsearch, and that has been very stable. It's actually 2 years in production. It's been running 2 years in production. So the nodes are deployed as stateful sets, and the data volume. So for the storage, for index storage, is using persistent volumes, and we have like daily snapshots to GCS running as a Kubernetes cron job. Now, there are two things, right? Initially, we were looking at, can we use a SSD disk because of the speed that we get in writes. That was not chosen primarily because in a GKE, if you wanted to have auto upgrades and auto repairs, etc., you can't use a local SSD, right? You don't get those advantages. And we, being a small team, we didn't want to deal with a lot of support and maintenance activities. That we want to have a streamlined DevOps involved. So for that reason, we used network at rest persistent volumes for storage. The biggest advantage that you get is upgrades are or even restarts of the cluster if needed are pretty fast. So what it does is pods are new pods. The new Elasticsearch version spinned up. The persistent volume is detached from the old pods and attached to the new one. And Elasticsearch, it doesn't even go into rebalancing the shards. It's pretty, it nodes are pretty fast, and the cluster goes into green pretty fast. So that was one of the biggest advantages. If we have to do any sort of operational activities, this helped us a lot. The second aspect is, of course, for speed reasons, we make sure that we had, any size state, we make sure that that index fits in the off heap of the pods as well via memory mapping. And of course, in the Kubernetes configuration, we specified the node affinity and zone-based shard allocation awareness in the ECK specification of the pods in nodes of Elasticsearch. We specify it. We use both N2 as well as E2 series of GCP machine types, and we use Kubernetes chains and tolerations for the node pool a lot. For example, like for all the data nodes, we know the specific type, and we have specific chains and tolerations associated with those node pools. So the affinity associated with those node pools, and we ensure that Elasticsearch data node should go only to a specific node pools, and then the master node should go to a different set of node pools and all of the microservices, like what you need, GPU, etc., goes to a different set of microservices, etc. Initially, we were trying to put a larger number of Elasticsearch pods into one GKE node. That led to outages. So even if a GKE upgrade happens, even if we, and then what we did is we finally put only one Elasticsearch node pod in one GKE node pool. Node in node pool, and that helped us. But even during an upgrade, when you have a larger Elasticsearch footprint, Elastic cluster footprint, what you see is when node upgrade happens, the cluster goes into yellow because it brings it on one node at a time, but it comes back up pretty fast. One of the things that we saw with Elasticsearch with ECK is typically the synonym files are mounted as config maps, but that is the size limit is 1 MB. So if your synonym file is greater than 1 MB, then what we use is a Google NAS that is mounted on all the Elastic pods, and we have a microservice to reload it from if there is a change in the file, etc. We use NDCG, normalized discount accumulator given algorithm, as running a Spark job to compute all the metrics, relevancy metrics, and we use JMeter as a microservice for load testing. Now, as I mentioned, right, we use Istio as a service mesh that connects the two clusters, GKE clusters that spread across the two regions, and that helped us to have regional failover capabilities, and as active like users in Asia would be routed towards our Singapore cluster, and users in Europe and the US will come to our US East cluster. So the load balancer would hit a network endpoint group neg of Istio, and then from neg it talks to the Istio ingress gateways, and we have deployed across the two regions, and from the Istio ingress gateway it goes to our search UI, things like that. And we use Cloud Armor for protection, and a single query goes through like around 13 microservices to perform the search in from Cisco.com perspective. So Prem, these are the different AI services that Prem talked about. I'm not going to go into it. As you mentioned, we have HPAs for all the microservices. Now, one of the things I would like to call out with use of NVIDIA Triton Inference Server, and it allowed us to host multiple GPU models, GPU-based AI models within the same GPU. That reduced the cost a lot. And so we visualize the metrics of Istio in Kiali, and we configure different timeouts, etc. So even if one particular metric is taking too much time, we have retries and timeouts that is set. And for one of the things that we did is for every query that comes in, the Elasticsearch time, etc., in real time are captured and they're sent to PubSub, and from there it goes in the BigQuery as well as Elastic. So the performance for every query, we can see it, and we have an ID that gets sent, the request ID that gets sent for every query, so we can track what query it was and what is the time taken in Elasticsearch, and that is used for some metrics analytics purposes. So what I just talked about, here is a visualization of it. At a high level, we have data sources, we have connectors that are running on-prem in Kubernetes Spark-based, publishing it into PubSub, and the data being stored in cloud storage. We have connectors in GCP running as Dataproc jobs, crawler running as Dataproc jobs, the document processing running as Dataflow, AI pipelines running as microservices. All the processed document goes into PubSub and get Logstash, runs the microservices, sends into two regions, R1, R2, US and Asia, and then it sends to Elasticsearch running on two clusters. There is a local Logstash running in each of the Kubernetes cluster, sending the data to the local Elasticsearch cluster. And as to the search side, we have the load balancer, which talks to the negs, corresponding to the Istio ingress gateway, and finally the microservices. So that's our end-to-end architecture. This is all the components. I'm not going to talk into it, but this is essentially all the components that talked about. Here we have a dedicated CI/CD pipeline with using Spinnaker. PagerDuty is alerting incorporated. Yeah, we have followed. Yeah, so we use Snowflake as a data store for all our relevancy signal calculation, etc. So yeah, so let me talk a bit into the journey. Sure, I'm going to wrap it in 2 more minutes. So let me talk about the journey. So before we started this journey, our team had zero experience in doing things in the cloud or even in Kubernetes for that matter. We've been running an Elasticsearch as Dockerized containers on bare metals. That was pretty much the experience that we had. So one of the things that we did is we upskilled the team before the start of the project. We had the team doing certifications, Kubernetes certifications, CKA and CKAD certifications before the start of the project. So before everyone started working on this project, it took almost a month and a half or 2 months for the team to complete that certification. So that helped the team to be on the same level before you start this implementation of the project. And then and there were cloud trainings taken as well, GCP trainings taken as well. That helped as well. So high level, we had a huge amount of focus on security, right? Because this confidential content and to do things right in the cloud is not easy. So huge amount of focus on security, modern architectures you talked about, DevSecOps, and making sure the performance is key, right? Yep, and that's pretty much that I had to talk about. I'm more than happy to take any questions.
So Prem, thank you both very much. That was fascinating. You've built something very big and very complicated, and thank you for explaining it to us. It's looks like an amazing system. So I'm going to open the floor now for any questions from our team. As ever, if you could type them into the Zoom chat. But we've got a small crowd here today, so perhaps we can open it up so people ask them in person. While you think about that, I'm going to ask my first question just to get it started. It's a kind of general question. On the enterprise search use case, how do you measure success? How do you measure what is a good answer to a particular question?
So we have metrics which talks about the dwell time, the engagement, etc. So from a metrics perspective, we look at how did the user engage, click on the question, click on the answer for the particular question. That gives us idea about the engagement. And for the relevancy, we have NDCG jobs which runs on a daily basis, which compared for a given query with all the changes that we make, how far we are doing in terms of the NDCG score. We get daily reports. Prem, if you want to add any, and of course, there's user testing, which helps us, our Cisco employees and domain experts testing to figure out if something is relevant, and we get a feedback back. Prem, if you would like to add anything more to it.
Yeah, only one thing that the click-through rate, we kind of track that. And then also the total amount of time spent on search. So this was relevant for our internal audience, our support engineers, that we can compare before we made the change and after, how long were they on an average spending time on the search activity. And it was interesting to see that since the 2-3 months that the new topic search has been live, the time they are spending is 15% less. So that is another indirect indicator that they're finding, because the rest of the query volumes in terms of what kind of queries they're asking has not gone away. So it's not like less work. It is more accurate work is resulting in less time spent on search.
So you're confident they're getting to the answer they need quicker?
Yeah.
Yep. And that we got good feedbacks without any soliciting. We got good feedback when we went live, and zero complaints. People are pretty vocal for internal search. People are pretty vocal if things are not working. And then, as Prem mentioned, the amount of TAC engineer hours saved is significant when it comes to the total amount of TAC engineers that we have. So it is significant employee productivity that we gain by rolling out the solution for our support search.
Fantastic, thank you. Okay, so we've got a question from Mark. He says, if I understood correctly, you mentioned you use the KNN plugin from AWS Open Distro for Elasticsearch. Did you manage to use this plugin while using the ECK operator to deploy your Elasticsearch clusters?
That's right. So that is what has been running for the past 1.5 years, I would say. We picked up the plugin. We had a Docker job which would build the plugin, and then in ECK specification, you can add in custom plugins. So it works seamlessly. The only thing I had to add is the Canon. There was a warm-up API that needs to be called every minute to reload the Canon index in memory, the graphs in the memory. That was only thing that I had to do on top of it to make sure that it's always up to date. But we are moving towards the native Elasticsearch vector search with the Atodex version of Elasticsearch. We have already installed it and it's working out well. It's not live yet, but for that particular implementation, you don't have to run this Canon warm API. So that works out of the box. Either case, we never had an issue with Canon plugin.
Okay.
Pretty fast.
Cool. So you're committed to Elasticsearch going forward as your engine. You haven't considered OpenSearch, for example.
Yeah, ECK works great. I've not seen an operate from OpenSearch. Someday they might get to it, but ECK works great. That meets their needs.
Gotcha. Okay. So while people think of some other questions, I've got one to fill the time. You mentioned something around boost prediction based on a blog from Elasticsearch. Could you share a link to that? Because that's something that was new to me.
Yeah, I'll find it up.
Fantastic.
So they published this in the MS Markov challenge. They actually published this. It came up in the semantic search. It actually came up high in the top 10 at one point in MS Markov. Yeah, I got it.
Great, thank you. And while Sujith is looking, do think of some further questions for Sujith or Prem.
Here is the link.
Fantastic, thank you. Oh yes, I think I may have seen that one, but I'll follow us up and take a look. Thank you.
Yeah, the bottom line is, if you have the right expertise within the team, it's easy to build up an enterprise's platform. The number of search team members is hardly, I think, 10 people in the team, full-time employees. And then the AI team is, around 10, 20 folks right now. Yeah, my point is it's pretty easy to build. If we could do this in 8 months, end to end, essentially anyone can do it if they have the right skill set.
Yeah, and it's a very fast time scale, I think, for building an enterprise search system. I think that's very impressive. We've got another question here. Cody asks, the choice to chunk documents appears to be a benefit for question answering for clear reasons. Have there been any negative trade-offs to chunking with respect to relevancy and or displaying the results at document level?
I think I need to clarify one thing there. We do organic search as well. So the only top 2 answers are powered by a Q&A search, as similar to Google featured snippet. The rest of the results at the bottom are powered by the organic native Elasticsearch as well. Yeah, so it's a bit of AI play there, but essentially the engine that finally powers the search is Elasticsearch. So we do a document level search as well. It's a mix of both of them. So we have a separate index for chunks, separate index for yeah, for the organic, the entire document as well.
Gotcha.
Yeah, so as to the relevancy, so the only thing that we see is if the question spans over multiple chunks, then we may or may not provide the right chunk to the end user. That's only down. But then we do top two, so we only display one chunk per document to the top. So apart from that, you have not seen one. And what we're doing right now is we're going to, in the process of moving towards a pure embeddings based approach. Using, like, we're trying out, going to try out things like the sentence transfer based similarity with Elastic along with some GPL, etc. So we are exploring those options. So the idea is for the Q&A search to be completely driven by embeddings, and then let the organic search be powered by Elasticsearch. See how the relevancy is.
I think one thing I'll add there is that some chunks are replicated across different documents, which may span different products. So if the product is not mentioned, then there is a challenge in picking the right chunk to show. And often they are similar, but so information-wise, we are not cutting short. However, showing a user a chunk from a document that actually relates to a different product is not very good. So that's a challenge we always have. And same thing happens with version numbers of software. Software version numbers, the documentation is for each version is sort of similar to the other one with some changes, but they're different documents. So that duplication happens that we have to guard against.
Yeah, I mean, I guess we're all familiar with that problem where you're looking for a particular technical item and all you can find is one that's just very similar, but not the same number, and you just can't be confident that's the right answer. Thank you for the answer to that one. I mean, it sounds like a lot of this is some of the motivations between the decisions you've made here are based around the fact, this is a technical archive of documentation and people are looking for answers to specific questions about specific items. There's probably less kind of exploratory search going on here rather than, it's very targeted. I need to resolve this issue kind of search. Is that true to say?
No, actually, Cisco.com. So we talked about two use cases here, right? One was the support search for a support that is internal, that's for internal employees or support engineers. That it is targeted. Most of the time, it is error messages being put in. Even though it's targeted for support engineers, we have our engineering teams using it, we have sellers using it, etc. So that's a very support-focused search, is a support vertical search in one way. Cisco.com search caters to both, targeted, exploratory searches as well as for, navigational kind of searches as well, right? Some of them very pointed, hey, here's the serial number, what's the warranty information, in certain cases, it's in just few terms. If it's just few and 2 or 3 words, we don't bother, trying to, provide a Q&A because it's so generic. And that's where the organic search would come in and answer the question. And they pretty much, such generic terms leads to landing pages within the product, so then the users can navigate to it, etc.
Got you. Fantastic. Thank you. Do we have any more questions for the team here? Okay.
Yeah,
so,
if there are questions, feel free to ping us offline with LinkedIn. More than glad to help. And we leverage open source a lot, and then happy to share back to the community, especially the crawler component, which probably would be the fastest open source crawler out there based on our analysis. So someday we'll open source it back to the community.
Wonderful. That's great to hear, because that's always a question, isn't it? There seems to be a lot of search engines, but very few crawlers. We always end up going back to Nutch or something like that. And I think we've all in our careers written a few crawlers.
I've seen Fast ESP crawler was one of the best crawlers I've seen.
Oh, we all miss Fast ESP, I think. We all miss Fast ESP. Well, all we can say is some of the team there are building Vespa, so that's cool. Anyway, thank you both, Prem and Sujith. Thank you so much for your talk. We will, as I say, we've been recording a talk, so if that's all gone well, we will have that up on Open Source Connections YouTube. It's going to be early next week because we will need some time to process that. But if you're able to share your slides, do please send them over and we'll put those somewhere as well, or a link to them. That'd be fantastic. So a couple more housekeeping things, just to remind you. If you can see that, there we go. So we don't have a next meetup talk, unfortunately. So if you have a meetup talk you can give, or you know someone you can ask to give it, please do get them to sign up or sign up yourself at the Haystack website, and we'll probably start the Haystack Live meetups in, I guess, May, if we have some talks submitted. Haystack itself, the in-person conference, 27th and 28th of April. Of course you're all coming. But to do check it out, there are tickets still available for the in-person component, and also we have online participation, but you'll miss a nice dinner and some drinks if you do that one. All the details on the Haystack website. We'd love to see you there. It's our first chance to welcome everyone back to Charlottesville. The day before Haystack, if you're in town anyway, there's a free event on e-commerce search being run by Renee Kriegler, our Director of E-commerce, who's been running this MICES, the Mixed Camp for E-commerce conference, very successfully in Berlin for a number of years. This is our first chance to bring it to the US. There's a free event focused around e-commerce search, and it's a bit more of a kind of unconference feel, a little less formal, but do come to that, and it's free to enter. OSC's training, we have our Think Like a Relevance Engineer trainings for Elasticsearch and Solar coming up in May, and then the next Learning to Rank training won't be until August, but do check out the training webpage and sign up there if you're interested. And I probably don't need to say this, but if you're not already on Relevant Slack, do jump in there. We've got 2,400 people talking about all kind of aspects of search and relevance. It's a great place to share ideas, share your cool projects, answer questions, help people out, and it's a great way to build our search and relevance community. So that's about it from me today. This has been Haystack Live. Thank you again to Prem and Sujith from Cisco telling us about their amazing project on enterprise search with Elasticsearch. We'll be back sometime soon. In the meantime, you have Haystack. Do take a look at the website and see if you want to join that. But this has been Haystack Live. I've been Charlie Hull from Open Source Connections, where the search and relevance people are very happy to host Haystack Live. Thank you again, and see you all again soon.
Thank you all. Thanks for your time. Bye.
Thank you.